Any of these questionable? Are we good? Oh, okay. So,
And number one.
okay, number one. So I don't know why. I think I should say 11.0. I think that might be a misprint.
That's
So
what I-
here, let's annotate on the board because I can do that. So I think that should be 11.0. Okay, so that's good. And then you had a question here. Okay, so it says a percentile is the percentage of data that lies below a certain value. Find the percentile score for 10.4. So 10.4 means how much data is below that. So there's 1, 2, 3, 4, 5, 6, 7, 8, and there's 20 pieces of data. So anything below 10.4 is, even though 10.4 is the median, all the values below that, there's 8 of them, so the 40th percentile. Okay? That help you out on that? Mm-hmm. What else could I help you on there? Let's clear that. 6, 7. All right. So median income of the police officers in Detroit is $46,400. Boy, they don't make money in Detroit. So that means half the police make less than that, or you could turn around and say half the police make more than that. So that's just the ins and outs of that. Good to see you. You didn't miss anything yesterday. We did a wind day because we had a lockdown. And then the average time it takes to drive to the Dallas airport from downtown Dallas is 27.4 minutes. Okay, so there's one term I want to make sure that you know. So the mean is the average. We can also refer to something as called the expected value. Okay? So if they say that the average time it takes to drive to that airport is 27.4 minutes, bless you, you should expect to take 27.4 minutes to get to that particular airport. That's basically. And the main thing is recognizing that mean, there's a term called expected value, and I'll make sure I flip back to that in the notes so you highlight that. All right. Then this Jim's ACT score was 46th percentile. So that means that 46% of the ACT scores were below Jim's. Or you could flip it around and say that 54% were better. Sarah's test score was an outlier on the physics test. So she was either way below or way above the scores. So if you saw like a whole clump of the data, it was either really far to the right or really far to the left of the data. There's actually something we will use that will verify something is truly an outlier. And then, let's see, moving it up. Calculate the mean pulse rate before exercise. Okay, so I'm going to move this down. So on Desmos, you could do this. You could plug in 50, 52, 53, 58, 59, 60, 60, 61, 64, 66, etc. Plug it in Desmos, and then find the mean of X1. That would find it. So they came up to 62.6 roughly. And then interpret the mean in the context. So the mean, this would be the expected pulse rate, or they have a typical pulse rate before exercising. Calculate the median of the pulse rate before exercise. So you find the middle of this data. Once you have it in, type in median. So they're finding it at 61. And bless you. Calculate a person who had a pulse rate of 68 after exercise. So you'd have to plug this data in. So you have 59, 62, 64, 67, etc. And then a 68. So calculate a percentile. So the values that are below 68 would be 1, We do 1, 2, 3, 4. There's 4 of them. So 4 out of the 15 total. So that would be a 26.7 percentile or 27.6%. And interpret the percentile in the context of this problem. So it says that 26.7% of all the pulse rates would be below a 68, while they're exercising or after exercising or something like that. Okay? Make sense? Questions? I think today is going to fill in a couple more gaps, which is always good. So that was something. That was 1, 6. 1, 6. All right. 1. So I'm on 1.7. So my goal between now and a week from today, I'll actually be out of the classroom again. So we'll do a quiz, and because I'm out of the classroom, you guys get to do the whole quiz together. Some of you are still missing the last quiz, so please come see me on an off period. It's not hurting your grade right now, but at some point I'm going to have to put a goose egg in to light a fire. So let's just make sure. And someone asked, is it okay if I come in here if you have a class? Of course it is. So, come on in. All right, so let me dim these lights so we can see this board. It's mainly so I can see it better. Everyone's good today? All right. Hey, 3-day weekend this weekend, huh?
Yeah. We don't get to do stuff on Monday.
Sleep in, I'd say. Sleep in on Monday. All right. So, study the following 2 data sets, data set 1 and 2. Okay. They both have a mean of 5. However, the first data set has values that are spread farther from the mean. Okay. So what that basically means is our first data set being 1, 3, 5, 7, 9, and the other one 3, 4, 5, 6, 7. The 1, 3, 5, 7, 9, the 1 and 3 are further from the mean than and then the 7 and 9 are the same. It's an equal distance, but they're a little bit more spread out as far as data goes. All right. So then we get to a word called the range. So the nice thing is, if you have the range, if like a 7 is your smallest, and you had the whole data set, and then let's say 25 is your biggest. If I wanted to find the range, I'm just going to go 25 minus 7. So I'm going to have a range of 18. That just means my data is spread 18 units from start to end. Okay? That's all the range is. It's pretty simple. It's not necessarily it's not a reading of the central part of data. It's just how spread out our data would be and for the range. So the range of the top one of data set 1 would be 9 minus 1 to give us 8. The range of the bottom one would be 7 minus 3, which would be 4. Okay, that's all we're really doing on those. Okay, so a lot of times the larger the range, the more spread out your data would be, meaning this. Remember I drew a normal distribution that kind of looked like this? If you have a really spread out range, it might look like this, where the tails are further apart, okay? And I know we're not dealing with a normal distribution at this point. We're actually, I believe today, going to get into some stuff. Okay, so, I'm going to tell you what the IQR is first, and then I'm going to show you, and then we're going to talk about standard deviation as well, but I'm going to show you how you're going to find all of that as well. It's relatively simple. Bless you. It's relatively simple to do with Desmos. Okay, so the first thing I want to talk about is something called the IQR. And the equation for that is Q3 minus Q1, And you're like, what's this Q stuff you speak of, Stirrup? I'll get there. And then the standard deviation by definition is the average distance from the mean. And I'll explain what that means as well. Okay? So the standard deviation can happen to the right. It happens to the right and to the left of the mean. If you go to the left, you're going in a negative direction. If you go to the right, you're going in a positive direction. A standard deviation, basically one standard deviation way. We will go out 3 standard deviations, but for one standard deviation from the mean, that means that 68% of scores are within one standard deviation. That goes to the left and to the right of that. And that's just a way of talking about your data. Okay? So again, I'm going to show you how to find the IQR using Desmos. I'm going to show you how to find the standard deviation. You, as students in 2024, should be very thankful that we have Desmos, because the equation for standard deviation is mean, nasty, takes way too long. We might see the equation just so you have the equation, but you'll never have to use the equation to get the standard deviation, because our buddy Desmos is going to help us out a lot. Okay? All right. So, lo and behold, yay. This is how we find standard deviation. Okay? Okay, so we're not going to follow the steps that they have there on the board, because that's if we have our graphing calculator and we have Desmos. So much easier. That equation down below is how to find the standard deviation. It's the square root of a whole bunch of stuff. It's the summation of a value minus the mean, and then you square it, and then you divide by the number in your sample divided by 1. And so if you had like just doing the 1, 2, 4, 8, 10 by hand on that, probably would take us 15 minutes to do. Or Desmos does it as fast as you can put stuff in the Desmos. So kind of like this Desmos. It's pretty helpful for me. All right, so I'm going to jump on Desmos, and we're going to look at that data set, and we're going to take a look to see how we find the IQR, and we're going to try and figure out if we can find the standard deviation on Desmos. Both are relatively simple to do. So if you have your computer or your phone, get your Desmos up and ready. Oh, good. I don't have any open windows. Okay, Desmos. Graphing. So I'm going to make a table. So I'm going to do a plus and a table, and then I'm going to go 1, 2, 4, 8, 10. Okay, just an X1. Seem okay so far? All right, so a few things before I get further. Standard deviation will not be a negative number. Now, standard deviation can be subtracted from the mean if you're going to the left, and that's okay. Okay, standard deviation, the reason why it's never a negative number is no matter what two numbers I subtract from each other, if I square whatever that is, when you square a negative, it's always a positive. When you square a positive, it's always a positive. N is just the number of items in your sample. Okay? So let's take a look what Desmos can do for us. All right, you can go down to the next thing. You pull up the menu, go to functions, and we're going to look for, let's see, find a histogram, dot plot, box plot, normal distribution. Yeah, it is. I was just looking to see if I thought there was one that would give me a whole bunch of information if I did it all at once. Number theory. Okay. All right. So you saw up here STD. That's not it. Standard standard deviation of x1. Standard deviation comes out to roughly 3.87. Okay? So if that's our standard deviation, we can go with that. I didn't get you though. We're going to take that tissue dance. I didn't get you that. No. You know how you make that tissue dance? Put a little boogie in it. Dad jokes all day long. I didn't get you either. What's wrong with you, man?
Crazy morning.
I think it's coffee. All right. So what that 3.87 means is of our data, our average distance is 3.87 away. Now, let me do this, and then I'm going to show you, and it's not part of it, but if I find the mean of x1, it becomes out to 5. So what I want to do is, you don't have to know how to do this at this point. I just want to show you. Normal distribution, I have a mean of 5 and a standard deviation of 3.87. And if I hit this, little plus. Okay. So what this basically means, if I go 5 minus 3.87, and then I go 5 plus 3.87, so do you see the big blue glob here? We can actually make this even more fun to look at because Stirrup has toys. All right. Do you see the blue area? Everyone see the blue area underneath the blue curve? Can't see the blue area. It's the blue shaded region underneath the blue curve. Make sense? All right. So what this means, the 5 here is talking about the mean. Okay? That's the average. If I go 1 standard deviation to the right, so I added 3.87 to 5, and if I go 1 standard deviation to the left, I subtracted 3.87 from 5. This area here, notice what this says. It says 0.6826. Okay, so it's always roughly a 68%. Okay, this is off a little bit because our standard deviation was 3.8729833461. So that's technically what I should have added to both sides. And as I add closer and closer, this will get closer and closer to 0.68. 0.68 is the decimal. If I make 0.68 a percent, I multiply by 100, so move the decimal 2 places to the right, so 68%. So
Do we need to know how to do that?
not yet.
Okay.
Not yet.
I thought you said that.
I was just trying to give you a visual. This is a super secret surprise. You're going to do this later, but don't worry, we're going to make it perfect.
Okay.
So what would be the standard deviation? Our average distance from our mean of 68% of our data is within 3.87 of what our mean is. Okay, that's really what it means. Now, again, this standard deviation here used this huge equation here, but it did it instantly for us because computers do arithmetic a lot faster than we can. Not that they're smarter than us, they're doing what we tell them to do, but I'm happy Desmos does what it is told. All right. So the next one is the IQR. Okay. So I'm going to change this, and I'm actually going to do a box, if I can spell box plot of X1. Oops, let's turn this one off. Okay, this is called the box plot. This is representing based on the same data. If I turn the normal distribution on, I do this. It's kind of hard to see my normal distribution because if I do a zoom fit, then my box plot doesn't fit because box plot is just hovering above the x-axis, whereas So if we go and actually find our box plot on here, let's see, where's our box plot? See, our box plot is like up there. It's all kind of a dorky looking thing where the normal distribution. So we're going to turn this off, hit the plus here. All right, here's the nice thing with this. Okay, this is a box plot. Sometimes it's referred to a box and whiskers. Basically, if you put something in your X1, you type in box plot as one word, parentheses X1. You don't worry about the offset and the height. You just kind of deal with it. If you hit the little plus button down below, it'll give you a box plot. Okay, so this is my minimum value down here. This is my maximum value. So if I needed to find the range, what I can do, I think it'll work. So you just you have to guesstimate it. So you'd go for your range itself, it'd be 10 minus 1. 10 minus 1 is 9. Our range is 9. Our quartiles, let's see if I can do this. How am I going to do this? Our quartiles, trying to think how I do it in my head. Okay, so let me, again, you don't have to have the box plot yet known, but this line right here, which is slightly to the left, this is actually our median. Does that make sense? That's our middle of our data. Our median is the 50th percentile. That means half my data is below it and half my data is above it. If you do a box and whiskers, and we only have 5 pieces of data up there, which is kind of hard to really make it work. But so from this little line to the left here, this has 25% of my data. This first rectangle here has 25% of my data. This rectangle here, even though it's bigger than the one on the left, it has 25% of my data. And then the region over here has 25% of my data. So the box plot is broken up into 4 different regions where if I'm talking about this region here where my arrow is, 25% of my data. This rectangle here, 25% of my data. This rectangle here, 25% of my data. This line out to the side, also 25% of our data. Okay. Now, if we include outliers, we can do this. It doesn't really matter because we don't have any outliers in this. The nice thing is Desmos, if you unclick that box, and you have outliers, or you click one of the two. If you have dots that are showing up far to the right or far to the left, those are actually outliers. But what I want to do, let's figure out some terms. Big rectangle. Still following me? Big rectangle is made up of 2 smaller rectangles. Does that make sense? Yeah. Everyone's following this madness? Okay. So the leftmost edge of my rectangle is called Q1. The median is actually called Q2. And then the right side of our rectangle, before the whisker comes out on the other side, is called Q3. So in order to find the IQR, which is called the interquartile range, the IQR, interquartile range, IQR, is the middle 50% of our data. Now you remember, I said this little line off to the left is 25%, this small rectangle here is 25%, this bigger rectangle to the right of it is 25%, to the right is another 25%. So if I add the first rectangle, 25%, and the second rectangle, 25%, if I do my math correctly, 25 plus 25 is 50. So that's your 50th. You're talking about 50% of your data falls in there. To find the IQR, you do this. What does it appear this line would be according to Desmos? What does this line right here seem to be?
9.
9? Okay. So write that down because I'm going to forget. So this is 9. Agree? Each one of these lines is 1. So I got 1, 2, 3, 4, 5. Okay. So what does it appear this would be about? About 1.5. So 9 minus 1.5. What's 9 minus 1.5? 7.5. My IQR is 7.5. It's Q3 minus Q1. And again, this line here, so I'm going to go off Desmos. So you can jot this down on some notes. So if you have a box and whiskers or a box plot, doesn't matter how it looks, 25% of my data falls in each of these regions. And when I say 25% of the data, that means if I plotted my data points, now again, I only plotted 5 numbers, which is kind of goofy to think about, but if I had more than 5 numbers, 25% there. This is Q1. This is the median, which is referred to Q2, okay? And then over here is referred to as Q3. And in order to find the IQR, we are going to go Q3 minus Q1. And this is 50% of data. Well, that means 50% of the data is outside of the IQR. Does that make sense? And that's always how a box whiskers takes place. Even if I have a dot way out here, if I had a dot out here, that would be an outlier. If I had a dot way down to the left, that would also be an outlier. So if we have outliers take place, we're not in this case going to have any outliers, bless you. So those are a couple of things. So, standard deviation is measured spread. More specifically, it is the attempt to capture the average deviation from the mean. So again, the standard deviation is 68%. If you remember 68%, you're going to be correct for like 99.96% of this class all year. Okay? I'll let you know when we're a little offbeat on that. Okay? And that just takes place. So with data sets that are much more spread out, standard deviation will be higher. So if I had, let's say I went and took all of the statistics classes between what I teach and what Mr. Anderson teaches, and I have like 62 students, and he has about 62 students. So that's 124 students. So that's a lot of data. So if we were to plug in like test scores for every student, okay, we could go and figure out the average, the mean. Average and mean are the same thing. We can figure out the median, the middle. That's 50th percentile, half the data above and below. And we can also figure out the IQR, Q3 minus Q1. You want a box plot in order to do that, and you just kind of start gauging it on Desmos, how it makes it work. And then we can figure out the standard deviation, which means that once I have my mean, 68% of my data or my scores on those tests would fall within one standard deviation. Now, if all of your data is the exact same, let's say I gave you a test and it was worth 10 points, and everyone got a 10, your standard deviation is nothing, is 0. So kind of keep that in mind, because I think you might see that on homework. Okay? So the last thing talks about your graphing calculator. We're not using the graphing calculator, we're using Desmos. So things that you want to make sure you have kind of in your Rolodex of tools is on Desmos. Maybe write on somewhere on that paper, you know, if you plug in data into X1. So STDEV, if you just type that in directly or you find it under the menu of X in X1 in parentheses, that gives you standard deviation. If I want to find the IQR, you're going to have to type in box plot X1 and then hit the magnifying glass at the lower left of the screen to show that. And then you have to kind of gauge what's the right side Q3 and what's the left side Q1. Subtract those. That gives you your IQR. Okay? Okay, fist to 5 on it for figuring out. Fist, you don't understand any of it. 5, you're getting this. I got some 5s. Got some 5s. I like it. I got a 4. On your 4, what can I do to make you a 5? More practice. So if I gave you the opportunity to start stuff and you could come up and ask me, would that maybe take you up a little further? I like it. All right, so this was 1-7. So in the homework, 1-7. Okay. So when you plug this data in on Desmos, you're going to plug in 10.1, 10.2 3 times, 10.3 4 times, 10.4 5 times, etc. into X1 and Desmos. So I would strongly encourage you to get a good start on this homework so you can ask me so I can try and help you on Desmos if you need help. Okay? And that's all I have for you. No applause, just throw money.